Hello friends, today I will discuss the Sumpners test. This is also called back-to-back test. This is also called the regeneration test. So here I will discuss definition, purpose, terms used, principle, circuit, condition, procedure, analysis, calculation of core loss, calculation of copper loss, advantages and disadvantages. So let me consider first definition. It is the test conducted on two identical single-phase transformers to find temperature rise at full load condition. Purpose: to know the temperature rise. Number 2 is to know the core loss and copper loss, both the transformers. Next, terms used: primary winding, secondary winding, core loss, copper loss, polarity test. First, let me consider primary winding. So with respect to this test, the windings which are connected in parallel are supplied with the rated voltage. With respect to this secondary winding, means these are the windings which are connected in series and they are supplied with the rated current. Then core loss. So here with respect to this, it is the core loss of both the transformers. Similarly, copper loss means it is the copper loss of both the transformers. Next, polarity test. Here is a transformer. This is one winding primary. This is another winding called secondary. So let us assume that the number of turns here and the number of turns are also same. So let us A2 terminal is connected to capital A2 terminal like this. Similarly, capital A1, small a1 are connected across voltmeter like this. Let us say voltage is applied to the primary like this. Then the voltages are induced in these two windings, that is here V1, here V2. So in the primary winding, the polarity of the voltage here is this is minus, this is plus, while in the secondary this is plus and this is minus. This A2 and this A2 are connected in series, means plus and plus are connected together. So means these two voltages are connected in phase opposition, means this voltmeter shows now the difference of V1 and V2, V1 minus V2. So for this transformer, because the number of turns on both the sides is same, so the voltmeter shows 0. So then we say these windings are connected in series opposition, which is desired nature here. Suppose this voltmeter shows some reading, means so one of the that will happen for this condition when the polarity of the one of the winding voltage induced is opposite, then we get some voltage induced in the voltmeter. Then such condition is called the windings connected in series shading, which is not desired. Next, principle. Primaries are connected in parallel with rated voltage, while secondaries are connected in series opposition to pass rated current and to find the iron loss and copper loss simultaneously. Circuit and conditions. So we require here two identical single phase transformers. Coming to the circuit, here we find the two transformers. This is one transformer, this is another transformer. This first transformer primary is here, the secondary is here. Similarly, this is the second transformer primary, this is secondary winding of the second transformer. Secondary windings of both the transformers are connected in series and they are connected to the supply via switch, voltmeter, ammeter, wattmeter and auto transformer like this. While the primaries of the both the transformer, this is primary of secondary transformer, this is the primary of first transformers. They are connected in parallel and they are connected to the supply via voltmeter, ammeter, wattmeter and auto transformer. This wattmeter shows the total iron loss of both the transformers. This ammeter shows the total no load current of both the transformers, whereas this voltmeter shows the rated voltage applied to the primary windings. Similarly, When this switch is closed, this voltmeter shows the voltage applied to both the series connected secondary windings, and this ammeter shows the rated current of the secondary winding, and this wattmeter shows the copper loss of both the transformers. Next, procedure. First, ensure the secondary windings are connected in series opposition. To get that, disconnect this auto transformer from the supply. Then close the switch. Then connect this auto transformer to the supply. Then apply the small voltage by varying this jockey and see this voltmeter reading. Since both the transformers are identical in nature, and if the voltmeter shows 0 reading, then we can say the secondary windings are connected in series and in phase opposition, which is desired. Otherwise, open the switch, bring the jockey to 0 position, switch off the supply, then interchange these two connections. Means you connect this terminal to the switch and this terminal to this terminal of the next transformer. Then automatically that secondary connection will become in series opposition. Next, connect the primary windings in parallel. This is the primary winding of the first transformer. This is the primary winding of secondary second transformers. So this and this are connected in parallel. Next, connect the secondary windings in series opposition via switch. So first step itself, we ensure that the secondary windings are in phase opposition. So now only close the switch. Now apply the rated voltage to the primary windings. So here we have the auto transformer. Vary this jockey, apply the voltage such that this voltmeter shows the rated voltage of the primary windings. So in that case, this ammeter shows the total no load current of both the transformers. This wattmeter shows the total core loss of both the transformers. Next, after closing the switch here, vary this auto transformer by giving the supply to this input of the auto transformer such that this ammeter shows the rated current of the secondary winding. Now note down all the meter readings. So this wattmeter shows the total copper loss of both the transformers. This ammeter shows the rated current of the secondary winding of both the transformers, and this voltmeter shows the total voltage applied to the secondary windings which are connected in series. Next, analysis. No load voltage across each primary winding is equal to V0. That is, this voltmeter reading is nothing but V0. Next, no load current in both the primary windings, that is I0T. So this voltmeter or this ammeter shows I0T. Next, no load current in each primary winding. Since these windings are connected in parallel, so the no load current in each primary winding means divide this I0 by 2. I0T by 2. So then core loss of both the transformers is given by the wattmeter here. This is the wattmeter. This will show the total core loss of both the transformers, that is W0T. Next, a rated current in each secondary winding of the transformer is ISC. So means this ammeter reading is nothing but ISC. Next, Voltage across two secondary windings is measured by this voltmeter with switch closed. Then the voltage across each secondary winding is given by VSC is equal to VSCT by 2. Next, copper loss in both the transformers is given by WSCT. Means this wattmeter shows the total copper loss of both the transformers. Then, calculation of iron loss. Core loss of each transformer is given by W naught, which is equal to W naught T divided by 2. Similarly, calculation of copper loss. Copper loss in each transformer is given by WSC is equal to WSCT divided by 2. Advantages. Large transformers can be tested without actual loading. Next, disadvantage. Getting the two identical transformers is difficult. So by connecting a thermometer here, we can also measure the temperature, and this test can be continued for longer duration.